740, 740, 740, 740, 740, 740, 740, and 740. Right, tell me when you got those in. Good? All right. Here's how we're going to find our deviation. Okay? We're going up here to L3, so highlight L3. Okay? And go L1, which is right above the number 1, so you have to hit the second key, minus L2, which is right above the 2. Okay? Now look what's going to happen. It's going to calculate them all of them right for me right away. So it's taking L 600 minus 740. 600 minus 740. 650 minus 740. So it's taking all these values here, subtracting our 740, and just doing it for us right away. Okay? That's our deviation. But we want what? The absolute deviation, right? So I have to take the absolute value of all these. Oh man, watch this. I'm going over here to L4. Yeah.
There's an L4.
Exactly. I'm going to do the absolute value of L3. You remember how to get an absolute value? Second catalog, absolute value, and I'm going to go L3. Parentheses. Yep. And I'll take the absolute value of all those numbers right there. How you doing, Skylar? All right. You got it, Keisha? Sammy? Know what you're doing? All right. So here's all of the absolute deviations of all those, right? Are you stretching, or you actually have a question now? Yes.
Is there a way to just like say the absolute value of L1 minus L2?
You could have done that. Yep. Yep. Oh, you have to go up here. You have to go up to where it's highlighted. So go down, go to. You have to go up to help. You're fine. You have to go up here at L4, and then type in absolute value of L3. Okay? So there's the absolute deviation, right? What do we want to find? The mean absolute deviation. So I need to add all those up and divide by 15, right? Well, is there a way to do that? Yeah, watch this. Okay? Hit quit. Second, and then above mode. It's in blue. Okay? Watch this. Go to catalog. Okay? Now these are all the different types of things they can do. I want the mean, right? Okay? Mean starts with letter M, which is written as a letter is up there in green on the divide sign, right? So hit your divide sign, it'll jump down to the M's. And I want the mean. Right there. Everyone at that point there? Okay, hit enter. What do I want to find the mean of? All those values in L4. So I'll go second, L4, parentheses, and there it is. 78 2/3. Quick way to do it. Okay. Now remember what we did at in L1? L1 was just all the room heights, right? Or room areas. If I go second catalog mean, if I wanted to, I could have done the mean in L1, and there's our 740. So instead of typing in all those, I can just put all of them in there. But the only thing about that one, I can't use the frequency. I have to type in all 15 of them. Okay? And I can find the mean of those if I want to. Just type them all in, just have out there. Just go mean, where's my dad at? Okay? So 78.6 repeating, or 78 2/3 is our mean, or absolute mean deviation. That's our absolute mean deviation. Okay? Everyone see how to do that? Alright. QI2 says to do it for Whittier. Over on top, page 50. Can you do it for Whittier? Okay, so go back to Stat, Edit. Okay? Clear everything out. Okay. What was our rooms in at Whittier, Sam? What was it? 652 of them? 2 650s, 3 700s. Wait a second. How many 750s? 2, 3, 4, 5, 6, 800, 800. Okay? There our mean was 130, so we're going to have to type in 130 each time. 13 of them. Oops, I got 760 in there. 730, 730, 730, 730, 730. There's 10, 11, 12, 13. Okay, so there's my mean. And I go up to L3, and I'm going to go L1 minus L2. There's all my deviations. Then I go up to L4 and go second catalog, absolute value of L3 parentheses. And there's my absolute deviations. Second quit, mean, yep, L4, and the mean was 70 or 39.2. Did you get that, Keisha? All right, that's how we use our calculators to find that. Okay. It says an abbreviation for mean absolute deviation is MAD. Mean absolute deviation, MAD, math. Okay. You should have found that the mean absolute deviation for Whittier is much smaller than the mean absolute deviation for Central. The rooms at Central are larger on average than those at Whittier. The range of the rooms at Central is also larger than the range of the rooms at Whittier. Do you see why it is probably causing the complaints of the school at Central are too small? Okay. So again, here's your algorithm for finding the mean absolute deviation. Okay. find the mean of the data value, step number 1. For each set data value v, find the absolute value of each deviation from the mean, which is represented by the absolute value of v minus mu. And then take the mean of the absolute deviations. Okay? Now the last part is talking about the shapes of distributions. Here are dot plots of a number of runs scored by Westview's softball team and the number of goals scored by its soccer team. Okay? So the first one is this softball runs scored in games. How many times they get shut out? Which means they didn't score a run. 1 time. What's the most that they scored? 12. Okay? And then the soccer goals, score for each one, etc. Okay? Some shapes of distribution are given special names. When most of the data are centered around one point and the values on the left and right are roughly mirror images, they don't have to be exactly, but roughly mirror images, the distribution is called symmetric. The distribution of goals scored by the soccer team is symmetric. When the upper half of the values extends much farther to the right than the lower half, leaving a tail on the right, the shape is said to be skewed right. The softball team's distribution has this kind of shape because most games are relatively low scoring, but a few have high scores. Likewise, when the lower half of data is much farther out, leaving a tail on the left, then the shape is said to be skewed left. If the distribution is roughly the same height for all the values, it's called uniform. Okay? And those are the kind of the basic shapes of what things are. Symmetric means I kind of got up here in the middle, and then it's somewhat the same on both sides. Okay? If it's skewed right, let's see what happens. Then it's going to have most of my datas are on the left hand and a few numbers out here on the right. Okay, so it says it has a tail right and skewed left is opposite. And uniform would be all the same height, pretty much all the same height going across. Okay? So if you think about it, if we went into a store, okay, and we looked at the pennies, and looked at the dates on the pennies in there, how do you think that distribution would be shaped? If I looked at the dates of the pennies in a store's cash register, what do you think they would be? Would the shape of the dates be symmetrical, skewed right, skewed left, uniform, they're all the same? How do you think it would happen? Yep. Why? Probably the coins in circulation are going to be the newer coins, right? You're going to find a lot of 1960s, 1970 coins in there. You might find some, okay? So you might find some in the 50s and 60s, but you're going to find a greater majorities in like the 1990s, 2000s, etc. Okay? So it kind of has this shape here. Okay? So I have a lot of coins, newer coins, okay? They're going to be in circulation then compared to other ones, my older coins. So this would be skewed to the left. Okay? My tail is on the left, so it would be skewed left. Okay? That's what we do when we talk about distributions. Great. Any questions on finding the mean of something? Okay? The mean absolute deviation, how we can do it on our calculator. Okay? Distribution shapes, whether it's symmetric or tail one way or the other. Right, you got the evens for tomorrow, 2 to 20. I will not be here tomorrow. I have a meeting, so if Nick and Sheila are back, someone teach them how to find those on the calculator, please. Have a glorious day.